students. Today we have Proposition 45, 45 of Book 1, which states, to construct a parallelogram equal to a given rectilineal figure and having an angle equal to a given rectilineal angle. Okay, so here we have our rectilineal figure. It could be 20 sides, it could be this one is 1, 2, 3, 4, 2, 5 sides. Okay, and here we have our given rectilineal angle. Thus it is required to construct a parallelogram equal in area to this and having an angle equal to this angle. Okay? Oh, for our proposition today, we're going to go to our bag of knowledge. We know that we construct a parallelogram equal to a given rectilineal triangle, given to a triangle. Construct a parallelogram equal to a given triangle. We know we can apply a parallelogram on a given straight line, we can equal, such that it's equal to a given triangle and having an angle equal to a given rectilineal angle. Okay, so this one we just constructed. Here we apply it to a given line. We do that right after. We also know that we're going to need to draw from our knowledge when you have two parallel lines and a straight line falling upon them, the angles, the exterior angle is equal to the opposite and interior angle on the same side, and that when you have two parallel lines and a straight line falling upon them, that the interior angles of that creating are equal to two right angles. So this and this are equal to two right angles. Then we're going to also use the proposition where we learned that if you have a straight line and two lines meeting at the same point on either side of it, and it happens to create adjacent angles equal to two right angles, then those two straight lines themselves will be in a straight line with one another and not some other line like this little black dashed line, okay? And then we're also going to draw upon our knowledge that two lines which are parallel to the same line are indeed parallel to each other. So two lines parallel to the same line are parallel to each other. Okay, so let's get started. And why don't we get started by dividing up. So here, it's, in general, I always want to do Euclid the way he does it, is think, okay, what do I have for my bag of knowledge that I could use? I got this thing about triangles. I need to construct a parallelogram. This is equal to a given rectilineal figure, but I know how to do it equal to a given triangle. So what do? Well, let's make a bunch of triangles and then make a bunch of little parallelograms and add them up. It's pretty simple. Okay. There's our one triangle. Here's another one. Okay. And here's our third triangle. Okay. So we're going to start off by using proposition where we learned that given a triangle and a given angle, we construct a parallelogram equal to that triangle and having that given angle. Okay, and I'm going to use the same colors to help your imagination. Make that a little bit more appealing, let's say. Just try to, when you're doing propositions, try to make it appealing to the imagination. Okay? So you don't want to construct, even though you know it's true, you want to construct a parallelogram that looks somewhat equal to that triangle. Okay, so it's believable that those two things are equal. Great. So here we've drawn upon this proposition where we know we can construct a parallelogram equal to a given triangle in a given rectilineal figure. Okay, I mean a given rectilineal angle. So here we have this equal to this and this angle equal to this angle. Great. Now we know also that we can apply to a given straight line a parallelogram equal to a given triangle and in a given rectilineal angle. So let's do that. Let's apply to this line here a parallelogram equal to this given triangle and in this given rectilineal, let's do this one green, so we'll go in the same order. Equal to this and with an angle equal to the given. Okay, so let's do that. A little bit bigger. Okay. So this equal to this, and this equal to this triangle. Okay, let's do it again with the red one. Apply, about the same size. To this line now, huh? So let it be done. Now we have this parallelogram equal to this triangle, and in this given, with this given rectilineal angle. Okay? So let's just color these things up here just to make sure you can see them. Blue here, blue, and green, green. Okay? So this equals to this equals to this, and this equals this. Now we just have to show, okay, so if, by the way, let's show equality. If this equals this, and this equals this, and this equals this, we know equals added to equals are equal. So this whole thing is equal to this whole thing. That's no problem. Now we just have to show that this thing that we have is one parallelogram, that it's not funky. Okay, so let's start by showing that the lines are parallel to each other. Remember, we know that if two lines falling upon, if a line falls upon two straight lines and it creates an exterior angle equal to the alternate interior angle, they are indeed parallel with each other. So this line and this line are being fallen upon by this line. Uh-oh, let me show you these things in a straight line first of all. No, let's do it this way. Let's do two things parallel to the same thing. This is a parallelogram and this is a parallelogram. Two lines parallel to the same line are parallel to each other. Okay, so these two are parallel. Great. And for the same reason, these two are parallel, because this is parallel with this and this parallelogram, and this is parallel with this and this parallelogram. So they're parallel to each other. Okay. So if this is parallel with this, and this is parallel with this, then these two are parallel. Okay, I did an extra step there, sorry about that. So we got this being parallel to this. Now we need to show that these are on, let me see if this is, okay, in this parallelogram, watch this. Now I'm going to show that this is one straight line. Okay, here's a parallelogram. We know that the interior angles of a parallelogram are equal to two right angles. So this angle and this angle in this parallelogram are equal to two right angles. But this angle equals this angle. So it must be the case that this angle plus this angle equal this angle plus this angle. Equals added to equals, the wholes are equal. Okay? So this plus this equals this plus this. But this plus this are equal to two right angles because it's a parallel line with a straight line falling upon them. Therefore, this plus this necessarily equal to two right angles. Two things equal the same thing or equal to each other. But we know that if you have two straight lines coming from a point on another straight line on opposite sides of it, creating adjacent angles equal to two right angles, those two straight lines are themselves in a straight line. So this is in one straight line. Likewise, this is in one straight line because these two are equal. These two equal two right angles. Therefore, these two equal two right angles equals added to equals. Therefore, this is in a straight line. Great. So this is one long straight line. Likewise, this is one long straight line. Okay? But this is parallel to this, so the whole is parallel to the whole. Great. So let's see. We've shown equality, and we've shown that this is parallel. This is parallel with this, and this is parallel with this. Quod erat demonstrandum. Great. So we know now that it's possible, given any rectilineal figure and as any rectilineal angle, it is possible to construct a parallelogram equal to that rectilineal figure and having an angle equal to that given rectilineal angle. Thank you. Bye.